This lesson, we're going to talk about solving linear equations. Our objectives are to understand what an equation is, to solve for the unknown, typically x, in a linear equation, and learn how to check your answer so you always get it right. So first, dealing with equations, equations have an equal sign. Okay, that's part of the name, equations. What this means is that whatever's on the left of the equal sign has to be equal to whatever's on the right-hand side. So for instance, if I say I'm going to leave in 1 hour, in your head you can translate that to she's going to leave in 60 minutes because 1 hour is equal to or the same as 60 minutes. If we talk about a pop culture reference, for instance, if we're talking about the king of pop, we're talking about Michael Jackson, or in hockey, if we talk about Flower, we're talking about the one and only Marc-Andre Fleury. So whatever's on the left has to be equal to the right, okay? So our goal with equations is to find the value of the variable, typically x, but it could be a different u, v, w, z, that makes the equation true. So our first example, we're not going to write anything down. We're not going to solve this like you may have done in a previous math class. We're going to think, find the value of x, so i.e., what value of x makes the equation true. So in our first example, we have x equals 7. So if we're looking, what value of x equals 7? Our answer here would be x equals 7, and that's because if we plug 7 in to x, 7 equals 7, which is a true statement. Next, something plus 7 equals 30. What does this something have to be? X equals 23. And that's because 23 plus 7, so we plugged it in for x in the original equation, and we'd end up with 30 equals 30, which is a true statement. Box these answers. Last, something minus 6 equals 12. What does that something have to be? X has to be 18. And again, because 18 minus 6 is equal to 12, and 12 is equal to 12. Okay? So that's just to brush up our ideas on what an equation is, understanding what it means when we're solving for x. So when it comes to solving linear equations, our goal again is to find the value of the variable that makes the equation true. When we're talking about linear equations, we're talking about equations that have just x or u. We're not talking about things like x squared, x cubed, anything like that. So our variable is really to power 1. Okay? So when we're talking about linear equations, we want to get rid of parentheses, i.e. distribute. We want to combine like terms. We want to get our variables to one side and our numbers to the other, and then we can find the value of x or whatever variable we're being asked to solve for. And then lastly, in all caps, check your work. If you check your work, you'll make sure that your answer is correct and that you've understood how to properly solve the equation. So a couple of examples here. Solve for x and simplify your answer. Okay? So in this case, what we'll do, we'll start off, get rid of parentheses. This allows us to see everything for what it is. So the 2 distributes to the x and the minus 2. Okay, so what I'm going to encourage you to do with your work is do one thing and write everything out to keep your work nice and neat. So I didn't do anything to the 11. I'm going to copy it down. Equals 2 times x is 2x. 2 times negative 2 is negative 4. Okay, so I've distributed the 2, and then this minus 5x stays as well. Okay, so the only thing I did was distribute the 2 to the x and the minus 2. Okay, so now what we do is we combine like terms. Notice the 2x and the negative 5x are on the same side of the equal sign. Okay, so if I have 2 of something, if you have $2 and I demand $5, you're going to be $3 in debt. So if we combine our like terms, we have 11 is equal to negative 3x minus 4. Our next step is to get our variables together and our numbers together, and now we're going to work across that equal sign. If I want to get rid of the 4 on the right-hand side, it's a negative 4. I'm going to add 4 to both sides. So you can write it horizontally, or you might have seen it stacked vertically. On the left-hand side, 11 plus 4 is 15. On the right-hand side, the -4 and +4 cancel out, and we're just left with -3x. You may see what the answer is from here, but I will keep going. This -3 is being multiplied by x. So in this case, we divide both sides by -3. 15 divided by -3 is -5, and this is equal to x. So now we're going to check our work. When we're checking our work, we take the value of x that we found and we plug it into the original equation. So we're going to plug it back into exactly what we started with. So in this case, we have 11. And since I'm checking, I put a question mark above my equal sign. That's just a note to myself wondering, is this true? We're going to find out. We have 2, and then I'm going to plug in the value that we got for x. And notice I'm keeping the original in one color and what we're plugging in for x in another color. Okay, so now we want to determine if this is true. We want to determine if the left-hand side is in fact equal to the right-hand side. So we have 11 equal. To simplify the right-hand side, use order of operations. So we're going to take care of the group first. -5 times -5. And then we take care of multiplication. We're still wondering if this is true. -5 times -5 is +25. So -14 plus 25 is 11. We end up with 11 equals 11. Okay, so what this means is that the value of x that we found, x equals -5, does make the equation true. So this is our final answer. X equals -5. So notice our answer is not 11. Okay, 11 equals 11 just showed us that what we found solves the equation, but the answer is x equals -5. Okay, so this was an example where we had variables on the same side of the equation. In our next example, it's going to be variables on both sides, so you can see how that's working. And so our first step is to get rid of the parentheses, so we're going to distribute the 3. 3 times x is 3x. 3 times +2 is +6. Now in this case, since our variables are on different sides, we have to move them. So for instance, sometimes what we'll see is just combining these variables to say, oh, -2x. That's not correct. These are on different sides of the equal sign. Okay? So you can choose whatever way you want to go. You can start with moving your variables to the left or moving your numbers to the right or vice versa. I'm going to add 5x to both sides. Okay. So now I would have 3x plus 6 equals, these 5x's would cancel out, -5x and +5x, and then I have -18. Okay. Notice now on the left-hand side, we can combine like terms. Since they're on the same side, this is where we combine them together. So we have 8x plus 6 is equal to -18. We want to move our numbers to one side, so I'm going to subtract 6 from both sides. So now we have 8x is equal to -24. I'm running out of room. Divide both sides by 8, and we end up with x equals -3. Check our work. So we plug it into the original. So we have 3 times x is -3. And we're trying to determine if this is true. Okay. So on the left-hand side, we do what's in the parentheses first, following order of operations. On the right-hand side, we have multiplication. -5 times -3 is +15. And so now what we have on the left is 3 times -1 is -3. And does this equal to 15 minus 18? $15. Somebody demands 18. You're going to be $3 in debt. And so in this case, we got -3 equals -3, which is a true statement. One thing to note that just happened by coincidence is the value of x that we determined and what we saw was true for the equation ended up being the same number. But remember on the last side, we got 11 equals 11, but x was -5. So just make sure you're remembering what the value of x is versus what you're doing when you're checking. Okay, so that's all for this lesson. If you need additional help, feel free to contact me. And there are also free resources available to you through tutoring and academic success coaching.